Hey everybody, hope you're doing great in the AI Academy so far, sponsored by the Black and Brilliant Network and Codecademy. Really excited to be a coach here. I wanted to give you guys a little introduction and talk about supervised learning today. So my name is Alexander Liss. I'm head of data science and analytics for Wunderman Thompson, which is a marketing technology and advertising agency. In my job as a regional team lead for data science and analytics, my job is to help connect clients with solutions through using data and analytics. And I really love this because you can really broaden people's horizons and get them to, think differently about the world and think differently about the marketing challenges they can solve with some of the innovative and transformative applications of data science. Today, I'm going to talk about supervised learning. This is a really important fundamental technique in the world of data science. Broadly speaking, there's kind of two core paradigms. There's supervised learning versus unsupervised learning. Unsupervised learning, which we're going to talk about in the future, is when you want to discover patterns in the data and you don't have a clear objective in mind. Supervised learning, focus of the next few weeks, in contrast to that, is when you want to get a specific and definite prediction through a modeling process for what an outcome is going to turn out to be. And with supervised learning, you can do two approaches. You can do regression or classification. Regression is one of the most well-known, I think, kind of classical statistical techniques. You want, or example like in Kaggle competitions is predicting the housing price of different units of real estate in Boston, sort of a classic numeric example where you want to predict a continuous numeric value based on factors like different, characteristics of the house, like, the size of it, how many bathrooms it has, etc. Another type of supervised learning you can do is classification, where you want to predict, what something is according to a predefined number of classes. And I'll talk a little bit more about this because this is a very versatile and robust type of process that I've used in many projects. Specifically, one example for digital media targeting is the classification model, specifically based on logistic regression, where you want to predict the type of car that someone's going to buy. These are the different classes, and in our model, the different classes were things like a Toyota, a Volkswagen, a Honda, a Volvo, that kind of thing. And my specialty within data science, if you're watching this channel, is really more sort of the interpretation and the explanation of these techniques. If you want a coach who can help you understand the mathematical derivation of the sigmoid function that powers logistic regression, they're probably really well-qualified coaches in this program who can help you. But I think my specialty is more the explainability and the communication aspect. And for logistic regression, for this particular project, one of the values of logistic regression is not just of multi-class logistic regression, I should say, is not just that you predict which class you think a specific person or observation is likely to belong to, but you get a probability of how strong you think that prediction is likely to come true. And those probabilities, you can do a lot with that. You slice the probability, on a score of 1 to 100 into 10 percentage point segments called deciles. And having this feature adds a lot of utility and versatility and explainability to the model, because as you look to target people with a specific message, depending on what decile they are in, according to the model, you can see kind of their response rate according to decile, and based on that, sort of what some of the core features or the core characteristics of the model are. And this is really important for explainability and optimization, because when you build a model, whether it works or it doesn't, either way, it's really important to know why it worked or why it didn't work, because data sets change over time, models need to change over time. You continually need to refresh and optimize your model, and having those those understandings, those diagnostics of why it's working or not, allows you to do that. So those are all the thoughts I have on supervised learning, and see you out there in the Slack channel, and I'll be back in a few weeks to talk about unsupervised learning.